Okay, now we're getting down to the meat of the whole thing, circuits. This is where we're going. So we're trying to make circuits, and all of this current discussion has been so that we could talk about circuits. This is a simple circuit. It's the very basicest, most basic of our circuits. And there's a positive side of the battery and there's a negative side of the battery. So our current is going to flow from the positive terminal of the battery. So remember, the current is our I, but it's going to go from the positive to the negative. So then it's going to come back into the battery like that. So the battery is our voltage source. So here's where we're going to get our voltage. It could be this is a 6-volt battery. It could be the little square 9-volt battery. It could be a AA battery that's 1.5 volts. It could be the socket that we plug our iPads into, so when we charge them. So that's the direction that the current goes, from the positive terminal to the negative terminal. And this is actually what a resistor looks like. So if you were to go to Radio Shack and say, hey, I want a resistor, this is what they would give you. If you opened up your electronic devices and saw, and these are little, these are usually like, ooh, much smaller than this. Oops, we got our pictures backwards. But this is usually much smaller than this, and generally they're only about 1/2 inch, less than a centimeter, in length. They're usually fairly small, but then they have wire ends on both sides. Another type of resistor, because really a resistor is just anything that's going to use our electrical energy, is a light bulb. So when we're talking about light bulbs are also resistors. And the little filament inside the light bulb, there's a little filament that goes like this. If you're using the old icky ones that use a lot of energy, but they're kind of nice for this kind of discussion. The current goes through here and then through the coil and then down, and when it does that, it generates a lot of heat, and so it glows. And so it's using the electrical current to create light. And so anything that is using your electrical current to create light is a resistor. Now, one of the things we do is, instead of drawing out like a battery like this, so we're generally not going to draw a battery like this, we're generally not going to draw light bulbs or little resistors, so we have circuit diagrams. So we're going to take all the parts of our circuit and stash them all off to the side. And a circuit diagram uses a long line and a short line, and that's your battery. And then it uses this squiggly to be your resistor. Remember, your resistor is either that little longish thing or your light bulb. And then it generally likes to make things in squares or triangles. They like straight lines. Straight lines are kind of nice, especially since a lot of these pictures are computer generated. So when you see the squiggly lines like that, that's your resistor, and then they'll generally be labeled with how much resistance they have. So that's 10 ohms of resistance. This is a 6-volt battery, or a 9-volt battery, or a 1.5-volt battery, or 220 volts like your dryer is plugged into. But the current from the battery always goes from the long terminal is your positive, and your short terminal is your negative. So it goes from the long to the short. That's the way your current goes. So which way do your electrons go? Remember, the electrons go in the opposite direction as the current. So your electrons go this way. That's an aside. We're generally going to be talking about current. But you should know that the electrons are going in the opposite direction. So here's what some of our circuit diagrams would look like. So this would be our simplest of circuits. This is a battery, and notice it's really 2 sets of those long and short lines. So it might be a combination of 2 5-volt batteries, wherever somebody's going to find one of those. But it's 2 batteries. Here's the long and the short, so that's one battery, and then the long and the short, that's another battery. It doesn't really matter. This could have very easily have been written as just one long, one short. Our current's going to come out of the positive And here's our resistor, and see it's labeled with 5 ohms. So it's labeled with its resistance. We can actually, given this information, we can actually calculate the current from the battery. Because remember Ohm's law? V equals IR. I told you we're going to do this ad nauseum. Okay, so we know we have a 10-volt battery. We don't know the current, but we know that we have 5 ohms of resistance. And so we find out that our current here is 2 amps. Okay, see, that was easy. It's not that hard. This is a simple circuit, and we're going to try to get all of our circuits boiled down to so that they look just like these. We're going to talk about that later, so don't get confused yet. Okay, this is our series circuit, and if you look at the series circuit, you can see that when the current comes out of the battery, it flows from the positive to the negatives, but it has to go through every resistor. It has to go through that one, then it has to go through that one, then it has to go through that one. Now, a series circuit could have 2 resistors, it could have 5 resistors. This is just an example, but since the current has to go through all of them, in a series circuit, we find that the same current flows through each resistor. So once we know the resistance through one of them, once we know the current through one of them, we know the current through all of them. And then V equals IR, so they all have the same currents, and they have different resistances, so they might have different resistances, so they might have different voltages too, but we will find that the voltages will add up to the voltage of the battery source. So these 2 ideas here are really important for you to remember, because that's one of those things that you can use to check yourself with later. So big idea right now, get these together, and in a series circuit, the same current goes through each of them, because the current doesn't have a choice. It has to go through all of the resistors to get to the battery. In contrast to a series circuit is a parallel circuit. And in a parallel circuit, my current actually has a choice. So my current comes here. Then once it gets to this spot here, this is called a node. Okay, that's going to be important later. But once it gets that spot, it has a choice. It's like, ooh, I could go that way, or I could go that way. And then once it gets to this node, it's like, ooh, I could go that way, or I could go that way. And so in a parallel circuit, the important thing to remember is the current has a choice of which direction to go. And the choice that it usually makes is the same choice you would make. It takes the path of least resistance. So which resistor it goes through, okay, some of it goes through all of them. There's a little bit of current through every single one of them. But more of the current will go through the smaller resistor. And that makes sense, okay? If it's a smaller resistor, it doesn't resist the flow of current as much, and so more of the current can get through it. So if you had a really small resistor, you would have a big current. If you had a big resistor, you would have a smaller current. But here's one of the important things to remember about parallel circuits. All of the currents coming from going through each resistor will add up to the current from your battery. So your current from your battery, your total current, is equal to the current through resistor 1 plus the current through resistor 2 plus the current through resistor 3. Keep going till you run out of resistors. But they will all add up. And that's another one of those big checks. And another big idea we use to see if we're doing things right is that we will find that the voltages in a parallel circuit are the same, because voltage is, remember, your potential difference, okay? And so if I start here at the battery, okay, here, okay, if this is a 12-volt battery, I'm going to use all 12 volts to get through there. The difference between the voltage here and here is 12 volts. Okay, this too, from here to here is still 12 volts, because if I'm here, if the voltage at the beginning is 12 volts, okay, I haven't used any of the voltage yet. I haven't used any of the voltage to get out of the battery. I haven't used still any of the voltage to get to here. I haven't used any of the voltage to get to here, and I haven't used any of it to get to here. So even way out here, your potential along this whole line, this is almost like it was a capacitor at this point. Along the whole line, the voltage there is 12 volts. Well, this is getting back to the battery over here, and there's nothing between the battery and this spot, these spots. So over here we have 0 volts. So 12 volts on this side, 0 volts on this side, so the potential drop across here is 12 volts. The potential drop across here is 12 volts, 12, 12. So the potential drop across each resistor is the same as the voltage of our battery, or they are at least the same as each other. So that's enough for today. We're going to, in the next video, simplify some more complicated circuits. We're going to talk about combinations of circuits, but that's enough for now. I'll see you tomorrow.